When supplying power to a separate building, especially one that is metal-framed, several grounding and safety considerations come into play. Specifically, the question addresses supplying power to a remote metal-framed building used as a smoking area fed from a 50 amp, 240 volts, single-phase circuit with two-phase conductors, one grounded conductor, and one equipment grounding conductor. The setup includes an outdoor subpanel with a 20 amp, 120 volts GFCI and a 30 amp, 240 volts GFCI circuit breaker acting as disconnect. The separate building is 6 feet away, supplied by direct burial cable. Let's address the grounding and safety aspects. Firstly, regarding installing an additional ground rod and bonding the metal frame, it is recommended to install an additional ground rod at the separate building and bond the metal frame to it using a grounding electrode conductor. Since there is no metallic pathway between the subpole and the separate building, this ensures a lower impedance path to ground for fault currents, enhancing safety. The grounding electrode conductor should be sized according to the requirements of the National Electrical Code, specifically Table 250.66, based on the size of the ungrounded conductors feeding the building. Secondly, several often overlooked or misinterpreted considerations need attention. Conduit type is one of them. Ensure the conduit used for direct burial is suitable for the application. According to the NEC, it should be rigid polyvinyl chloride conduit, RNC, or Schedule 80 polyvinyl chloride conduit, especially where physical damage is a concern. The burial depth should also comply with NEC Table 300.5, which specifies the minimum burial depths based on voltage and conduit type. Regarding the bonding of the conduit at the separate building, it is critical to bond the incoming conduit at the separate building to the grounding electrode conductor using appropriate connectors listed for grounding and bonding. This ensures that the conduit is properly grounded, protecting against electrical hazards. Suitable connectors include grounding bushings and bonding jumpers. GFCI protection is an important aspect. The GFCI circuit breakers in the subpole offer essential protection against ground faults. However, it is advisable to install additional GFCI outlets or devices within the separate building, particularly in areas where moisture may be present, to provide enhanced protection against electrical shock. The NEC requires GFCI protection for receptacles in readily accessible locations in damp or wet locations. Adequacy of the circuit breaker protection is another consideration. Verify that the 50 amp circuit breaker at the remote location is adequately sized to handle the combined load of the general lighting circuit and the heating circuit in the separate building. Perform a load calculation in accordance with NEC Article 220 to ensure that the circuit breaker is appropriately sized and provides adequate overcurrent protection. Furthermore, wire sizing is important. Use appropriate wire sizes for the circuits, considering the length of the run and the load requirements. Consult NEC Table 310.15b16 to determine the ampacity of conductors based on their insulation type and ambient temperature. Also, consider voltage drop, especially for longer runs, to ensure that the voltage at the separate building is within acceptable limits. Equipment grounding is another key consideration. Ensure that all electrical equipment in the separate building, including light fixtures and heaters, are properly grounded. This involves connecting the equipment grounding conductors to the equipment grounding busbar in the subpole and ensuring that all metallic enclosures are bonded together. For metal-framed buildings, the metal frame should be connected to the grounding electrode system. Other factors include intermediate pull boxes. If the separate building is located more than 6 feet away from the subpole and the conduit run is long, it may be necessary to install intermediate pull boxes along the conduit run to facilitate the pulling of conductors and to comply with the maximum allowable conductor fill requirements for conduit. Expansion joints should also be considered. If the conduit run is exposed to significant temperature variations, expansion joints should be installed in the conduit to accommodate thermal expansion and contraction. These expansion joints prevent damage to the conduit and conductors. Surge protection is also recommended. Consider installing surge protection devices at the subpanel to protect against voltage surges caused by lightning or other electrical disturbances. Surge protection devices divert excess voltage to ground, preventing damage to sensitive electronic equipment. Additionally, labeling and documentation is crucial. Label all circuit breakers and equipment clearly to indicate their function and the areas they serve. Maintain accurate documentation of the electrical installation, including wiring diagrams and load calculations for future reference. The grounding electrode system at the separate building should consist of at least one ground rod, but 2 ground rods provide better protection and lower impedance to ground. The ground rod should be at least 8 feet long and spaced at least 6 feet apart. The grounding electrode conductor connecting the ground rods to the building's grounding system should be sized according to NEC Table 250.66. Also, ensure that all metal parts of the building's electrical system, such as metal conduit, junction boxes, and enclosures, are properly bonded together using bonding jumpers or other approved methods. This ensures that all metal parts are at the same electrical potential, reducing the risk of electric shock. Remember that local codes and regulations may have additional requirements beyond the NEC. Always consult with a qualified electrician and local authorities to ensure compliance with all applicable codes and regulations. The neutral conductor should be isolated from the equipment grounding conductors at the subpanel in the separate building. This means that the neutral conductor should only be connected to the neutral busbar in the subpanel, and the equipment grounding conductors should only be connected to the equipment grounding busbar. This separation prevents unwanted current flow through the equipment grounding conductors, which can cause nuisance tripping of GFCI circuit breakers and increase the risk of electric shock. The metal frame of the separate building should be bonded to the grounding electrode system using a grounding electrode conductor. This conductor should be sized according to NEC Table 250.66 and should be connected to the metal frame using approved bonding methods such as exothermic welding or bolted connections. The bonding connection should be accessible for inspection and maintenance. Any outdoor receptacles installed at the separate building should be weather resistant and protected by weatherproof covers. This protects the receptacles from moisture and corrosion and reduces the risk of electric shock. The wiring methods used for the circuits in the separate building should be suitable for the environment and the type of construction. For example, if the wiring is exposed to physical damage, it should be protected by conduit or other approved means. All electrical work should be performed by qualified electricians who are familiar with the NEC and local codes. This ensures that the electrical installation is safe and compliant with all applicable regulations. Before energizing the circuits, thoroughly inspect the entire installation to ensure that all connections are tight, all equipment is properly grounded, and all safety devices are functioning correctly. This helps to identify and correct any potential problems before they can cause harm. Regularly inspect the electrical system to identify and correct any signs of wear, damage, or corrosion. This includes checking for loose connections, damaged wiring, and corroded ground rods. Regular maintenance helps to ensure the continued safety and reliability of the electrical system. Consider using a combination of GFCI circuit breakers and GFCI receptacles to provide comprehensive ground fault protection throughout the separate building. GFCI circuit breakers protect entire circuits, while GFCI receptacles protect individual outlets. This combination provides multiple layers of protection against electric shock. Install arc fault circuit interrupters are sized to protect against arc faults, which are a common cause of electrical fires. A size detects arc faults and quickly de-energize the circuit, preventing a fire from starting. If the separate building is located in an area with a high risk of lightning strikes, consider installing a lightning protection system to protect the building and its occupants from lightning damage. A lightning protection system consists of lightning rods, conductors, and grounding electrodes that provide a path for lightning current to flow safely to ground. When installing electrical equipment in the separate building, follow the manufacturer's instructions carefully. This ensures that the equipment is installed correctly and operates safely. Always use the proper tools and equipment for the job. Using the wrong tools can damage equipment and increase the risk of injury. If you are not comfortable working with electricity, hire a qualified electrician to do the work for you. Electricity can be dangerous, and it is important to take precautions to avoid injury. Before working on any electrical circuit, always turn off the power at the circuit breaker or fuse box. This prevents the risk of electric shock. Use a voltage tester to verify that the power is off before touching any wires or equipment. This ensures that the circuit is energized and safe to work on. When working on electrical circuits, wear appropriate personal protective equipment, PPE, such as rubber gloves and safety glasses. This protects you from electric shock and other hazards. Never work on electrical circuits in wet or damp conditions. Water conducts electricity, and this can increase the risk of electric shock. Be aware of the location of underground utilities before digging. Contact the local utility companies to locate any underground cables or pipes before you start digging. This prevents damage to the utilities and reduces the risk of injury. Store flammable materials away from electrical equipment. Flammable materials can easily ignite if they come into contact with sparks or hot surfaces. Keep electrical equipment clean and free of dust and debris. Dust and debris can accumulate on electrical equipment and cause it to overheat or malfunction. Never overload electrical circuits. Overloading a circuit can cause the wires to overheat and start a fire. Use a circuit breaker finder to identify the correct circuit breaker for a particular outlet or appliance. This prevents you from accidentally turning off the wrong circuit. Replace any damaged or worn electrical cords immediately. Damaged cords can cause electric shock or fire. Never run electrical cords under carpets or rugs. Cords can overheat if they are covered, and this can start a fire. Use extension cords safely. Make sure that the extension cord is the proper gauge for the appliance that you are using and that it is not overloaded. Unplug appliances when they are not in use. This saves energy and reduces the risk of fire. Have your electrical system inspected regularly by a qualified electrician. Regular inspections can identify potential problems before they become serious. Teach children about electrical safety. Explain the dangers of electricity and how to avoid electric shock. Post emergency contact information near the electrical panel. This includes the phone numbers for the fire department, the police department, and the local utility company. Keep a fire extinguisher nearby in case of an electrical fire. Make sure that the fire extinguisher is rated for electrical fires. Know how to shut off the power to your home or building in case of an emergency. This can prevent further damage and reduce the risk of injury. By following these safety guidelines, you can help to prevent electrical accidents and ensure the safety of your home or building.